Good afternoon. Let's give you a kind of heads up on what we're doing. I'm going to be working on questions involving coordinates and essentially drawing lines. So today's pretty much breaking into three main chunks. The large part of today is going to be concerned with how do you draw graphs of lines. And the two main kinds of equations are ones that look like this and other ones who look like that. And we're going to look at how do you graph them. I'm going to kind of do it in paper, but really in your case, it's going to be done in WebAssign. And once I've done a few on paper and kind of get you the gist of how it's going to work, we're then going to go over and look at how you get WebAssign to do the same thing. So there are two main kinds, as you can see. There's this one here. And if you want to know what this one here is called, this one here is very often called the slope-intercept form.
I can just see the snake just now.
Right, I think I will just mute some people for background sounds. There we go. So what we are looking at here are lines that look like this, and we're going to look at how do you sketch them, how do you plot them. And then we've got these ones here, and when an equation is written as so many x's plus or minus so many y's equals a number, and it's very often called its standard form. So if I describe an equation of a line as its standard form, it's probably going to look something like this. If I describe a line and say it's in its slope-intercept form, it's going to look something like that. So there are a whole bunch of questions from 2 to, well, various other numbers here. They too are not there. But 2 to 6 and 10 to 14 are going to be essentially doing that. And then there's some questions in the middle that we'll come to, and where we're looking at, well, how do you draw graph lines when you're just told the slope and a point on the line? And that's purely going to be done. Again, you're going to be doing it on WebAssign, but we'll show you how to do it on paper before that. And then the last two are estimates of equations of lines. So they'll give you a picture, you know, whatever it is. And you're going to try from a choice of 5 or 6 choices, which one of these is the right equation. That's the kind of the overview of what's going to happen today. So let's get into the details. Let's look at number 1. How to graph lines with given equations. Right. Well, they're not that dissimilar, the method we're going to use. So, for instance, if I wanted to draw that line on paper or using WebAssign, what I would do is I would create, I like to do it as tables, 3 points that I know are going to be on the line. And in some questions, they tell you the points, but more often than not, you're going to be the person who chooses the X and or the Y's. Normally, when it's written in this form, it's a good idea to pick the X's because it's less work. And if you're not sure what kind of X's to pick, 0, 1, and 2 are pretty good choices. And we looked at that last time. And when you know X is 0, you plug it in here. 3 lots of 0 plus 2 give you a Y coordinate 2. And you plug in 1, 3 lots of 1 add 2 gets you 5. And when you plug in 2, 3 lots of 2 add 2 gets you 8. And what this table essentially gives us are the coordinates of 3 points. We remember doing that last time. And I think it was Charlotte that answered it very well when I went and said, why did we give 3 points? And she went and said, well, it's just to be safe, right? Because, you know, if you screw up, you can't tell with 2, but if you do it with 3, if they're not in a straight line, you know you've screwed up and you go and check it. So how do you physically do that? Well, I got some square paper for a change. I just went online and printed some. So hopefully, can you see the squares? It's hard to tell what you can see. Okay, good. So if you imagine me doing a little X and Y axis, this is how you would do it in paper. And you'd probably use a scale of 1 box represents 1. I bet you I didn't do enough room, did I? 1, 2, 3, 4, 5. I didn't. Never mind. The moral of this story, oops, is plan ahead. So 0, 2, 0, 1, 2. That gets me that guy there. That's 0, 2. And the next one is 1, 5. So you go 1, 1, 2, 3, 4, 5, 5. And there's your second dot. And then 2, 6, 7, 8. There's your third dot. Do you see that the 3 points are on the same straight line? Right? That's a really good sign, because what that probably means is that I've done the table correctly. And then I get them together and I try my best. And you draw a line all the way through. And I have now sketched 3x plus 2. And we normally put little arrows on the line because this particular graph goes on forever, right? It doesn't just stop at the top and the bottom. It keeps going, forever. And so the little arrows are there to indicate that. I think you agree that's a pretty straightforward approach, right? There's not too many button pressing. You can do most of it in your head. And that's great. We like questions like that. Now, in this second example, again, they're all the same question. They want you to draw the thing. We call it graphing it. And I don't have any real reason to change. So I'm going to do 0, 1, and 2 again. And if you plug in 0, you get -2 times nothing is still nothing, and then you add 1. Then -2 times 1 is -2, and you add 1. Okay, something's not right there. Good. You get -1. And 2 lots of -2 is -4, but then you add 1, and you get that. So I've got my guy. And the first one is 0, -1. The second one is 1, -1. And my third one is 2, -3. And here goes. 0, -1 would be here. Well, let me do this and show you why I know I've done something wrong. 1, -1 went here, and 2, -3 went here. Can you see my 3 dots are not in the same straight line? You see that? First dot, second dot, third. There's a kink.
Can you push it up just the tiniest bit, like an inch higher?
Is that? Will that work?
Now
right.
I can see it.
Right. Can you see my 3 dots? They do not match a straight line. I screwed up. Can anybody see where I screwed up?
I can see.
You did 0, -1 instead of 0, 1.
Now, if you do 0, 1, can you see the perfect straight line? Now. And we have managed to get the same guy. There we go. So when you are doing it, did you see the advantage there of having 3 points. If I had only done 2 points, wouldn't it look totally okay? Because 2 points always make a straight line, right? No matter where you draw them, you're going to get a straight line. But when I did 3, I found that I'd screwed up, and I went and I said, oh, what did I do wrong? Oh, I did this right, but then I wrote it down wrong, right? Which is easy, I guess, to do if you're not careful. Are we cool with that one? 3 points. Why don't we just pick 0, 1, 2 until we don't need to anymore? Well, let's try that one. Now, all I did with this one is that I made, well, not so much made, but the question I gave you had a fraction. It has a half x. And the reason I did that is that I wanted to show you that sometimes you can't always pick 0, 1, and 2. Now, you might say, well, I could. Well, I guess you could, but isn't it kind of hard to plot 2.5 accurately, or 3.5 or something? You can do it. But imagine it was, which my next question is going to be, that it was an even uglier fraction, in which case you really do want to have a backup plan. So if this is a half, I am not going to choose 0, 1, and 2. I'm going to choose 0 because 0 kind of works for everybody. But what do you think my next 2 x coordinates are going to be? Instead of 1 and 2, what do you think I'm going to pick?
2 and 4.
I am. And the reason I'm picking them is, doesn't that work better with a half?
Yes, because you take
Right.
the 2.
2,
Yeah.
4, 2,
Okay.
4.
Plug in 0 and you get 3. Plug in 2, you get 4. Plug in 4, you've got 5. Do you see we now have some quite nice points that are easy? I prefer, if I can possibly do it, I prefer to always have positive, well, maybe not positive, but whole numbers at least, because they're just easier. So 0, 3 would be 1, 2, would be here. 2, 4 would be here. And 3, 4, 5 be here. And when I draw, yep, they all match up nicely. I draw my straight line. I put my little arrows on it, and I write down what the equation is so everybody knows which one I'm doing. So, a quick recap of what we've done. We've done equations where it was a positive nice number like 3. We've then done one where it was a negative coefficient of x, -2. We did this one where it was a fraction next to the x. And the last possible kind of situation that I'm going to deal with is, what do you do when the fraction is even uglier? If you tried 0, 1, and 2, can you trust me, you get really ugly coordinates that it's going to be really hard to plot easily. So I'm going to stick to my 0 because I like 0. Who do you think I'm going to choose for the next 2 x coordinates?
5 and 10.
Why? That's correct. Why was that your choice?
Because the denominator is 5, and then the
Right.
next increment that would make sense would be a 10.
Right. So essentially, when you have a fraction like that, just like she was saying, if this is 5, will you make these guys in the 5 times table? If this was 3/4, go 048. If this was something with 7ths in it, I guess you go 0, 7, and 14. So that tends to make your life a lot easier, because when you plug in the numbers, you tend to get nice whole numbers for the y coordinate. 0 gets you 2. If you plug 5 in here, you get -1. And if you plug 10 in here, you get -4. So I'm going to be plotting the points 0, 2, 5, -1, and finally 10, -4. And I need another piece of paper. So here we go. Trying to plan this a little bit. So there's my X and Y axis. And 0, 2 would go about here.
How did you get -1 on that?
That one here?
Yes, when
yeah.
I did the 3
I
by
hope
5,
well,
when I did the fraction 3, 5 times the 5, then I got a different number. And then when I
you
added,
got -3, and -3 add 2 gets you -1.
oh, I missed the negative. Okay, never mind. I'm going
Okay.
back to my.
So 0, 2, then 1, 2, 3, 4, 5, -1, which is, well, I guess I should put the 5 up here. 5, -1 goes there. And there's 10, and -4, and 10, -4 goes here. So if things work out well, yep, they are all on the same straight line. And we've now done that guy. So if you get an equation in its slope-intercept form, do you see that you can find a table of values, and you can find the values that go with each x that you chose, and that generates 3 points. And then you plot those 3 points and join them up by the single straight line, and little arrows at the end, and you're done. Are we good so far? So what I'm going to show you now is how you do the answers to homework questions, which these are upside down somewhere. In other words, how do you get these guys into WebAssign, right? Because you can't just take a picture and do it. It doesn't work like that. So we saw this last time, but I think the more times you see it, I think it should help. What I've got right now is, I'm just using the grid here, not the question. So if I get this guy here, I can go to each one of the questions that I've done with you and show you how we do them. So the first one we did was 3x add 2, right? And I got the point 0, 2, 1, 5, and 2, 8. So you go up here and you click on that guy. And then you go 0, 2, there, 0, 2, and you make a dot. And then you go 1, 5, and you make the second dot. And I won't get a chance to do a third dot here, because when I click on this, it does the line. So you might want to do it on paper first to make sure there isn't a little kink. But if you don't choose to do it that way, do you see that the way WebAssign works is, once you give me 2 dots, it's going to draw the line for you. So your third point won't necessarily ever get used in WebAssign, but it's still a very good idea to do 3 points anyway, right? Get into the habit of doing 3. Okay, now the second one I had, so I'll just clear that out of the way, was 0, 1. That's 0, 1. Oops, I forgot. Click on that. Make sure you're on that. That should be highlighted. Then you go 0, 1, click, and you go 1, -1. And there's your line.
Professor, will we ever need to use the other options in that creating a line on the left-hand side?
So let's check. So are you asking, will you use this one or this one?
Yes.
No, you won't need to worry about those. In fact, there's quite a lot of things in this that you won't need to worry about. You won't need to worry about this one. Don't even know what it does, but we won't be using it anyway. So as far as the lines are concerned, you're going to use this one. Now, when we come to do curves, you're going to use other features, right? But that's the only one you ever use on the lines. It went black for some reason. Are we good so far? Now, there is a couple of drawbacks to WebAssign. The first one is pretty minor because it probably won't affect the vast majority of your answers. But can you imagine that you might have got in your table, one of your points might have been 12,5, right? Just for argument's sake. Do you notice in WebAssign, you can't draw numbers if they're bigger than 10? You can't plot them. So, but you've got 3 numbers, so hopefully 2 of them fit. So just pick the 2 that fit and you'll be fine, right? Now, if you, I don't know how you could do it, but I guess if you tried hard, you could. If you end up having a whole table of values and none of them are between 10 and -10, then you've probably picked bad X values, right? You may have to do the table again. Maybe 0, 1, and 2 was a bad choice. Maybe you should have done -1, -2, and -3. Maybe that would work better. No, so if it happens, I doubt it's going to happen at all based on the questions I've seen, but just in the off chance, you know, adapt. Do you feel comfortable now about how you would graph, that's a word we use for drawing, a line when you're given its equation? So these guys becoming these guys.
I have a question, please, Professor.
Yes, Naja.
If I have not like round numbers,
Yes.
how do I plot them?
Well, the first trick is to avoid not having nice round numbers. So if you've got a 1.5 or something like that, is that what you're thinking maybe, or something even uglier than that?
Well, for example, last quarter in mathematics, we had such questions. There are like big numbers for like 1,120.
Yeah. WebAssign, you're not going to need to worry about that because WebAssign won't allow it as a question. You won't get that. That won't happen, basically. The questions that you're going to get to draw will have to fit within a 10 by 10 window, just like the ones we saw, right? So -10 to 10 and vertical and -10 to 10 horizontal. So you won't get to plot, you know, 2,000, 5,000, right? So that problem doesn't exist. So you don't need to worry about it. I was thinking you might be talking about, well, how do I plot 1.6, 3.5? I don't know how you would get that, but let's imagine you could get that. And you're thinking, can I do that? Well, I would avoid doing it, but I can show you how you could do it nonetheless if you end up with something and you haven't found a way to avoid it. So I'm going to return back to that grid and I'm going to show you how I could do 1.6, 3.5. Right, so you go here, double check it's on it. And that's where I think 1.6 is. I know I'm not perfect. And that's where I think 3.5 is. And I'm doing a click. Right. And let's say the other point is up here. Now, if you click on the line, do you see it actually gives you the coordinates of the 2 points? So I can go to this one and I can change this one to 1.6. And I can change the other one to 3.5. So all I did there is roughly put where I thought it was, knowing I'd be wrong. But once the line was drawn, I click on this little guy here, right? And I change the numbers to what I want.
Okay, but first of all, you will need to put coordinates as like regularly, right?
Yeah.
Not
Like
at
so if it's 5 and a bit, comma 6 and a bit, just pick 5, comma 6. Just get a dot that you can work with, and then go up to that little thing and change it to the real numbers. Now I want to try some because I don't think it's going to work, but let's just try it for fun and
that
giggles.
sounds good.
Let's put 500, 900 in and see if WebAssign will just adjust itself to fit. I've never tried this, so I'm about to find out. And the answer is it can't do it. So you're never going to get any number bigger than 10 or less than negative 10.
Okay, thank you very much.
Okay,
So,
we in general, class, are we good at this? Can I move on? Or do you want to see more of this particular question?
I have another question, please.
Oh, go for it. What you got?
So I was doing homework with last one that you gave us, and there were two questions, number 13 and number 12, and I couldn't understand how am I supposed. That was so graph the line, and the equation says just y equal -3, and that's it. How should I calculate coordinates for the line?
Well, if you hold on, we will eventually get to those questions and you shall see.
Okay,
Okay.
thank you.
So we have got these guys. I think we're good to go on these guys. Can we move on? Okay, I got you. We can move on. So our next guy in town, right? The next kind of situation that we're going to deal with are equations that are written in what's called their standard form. So the one that I've got here, and I'm going to move my windows around so you can see what I'm talking about. We're going to graph lines that look like this, and they're called standard form. And the first one I've got is 2x plus 3y equals 12. They are typically going to be harder to do. They just are. It's going to look like I'm not doing anything different because I'm not. I'm going to pick three points and get their coordinates. Now, in some questions, I can just go 0, 1, and 2, right? And that might work. But there's no need for you to pick x's. Do you know you can pick y's? You could pick a y as a number and get the answer, or you can pick an x as your number. So I'll start off with my favorite guy, x equals 0. Now, if you go to the original equation, and you want to know what y goes along with a 0 for x, you plug 0 in for x. And you get 4. So that's a good point. I like the numbers. They're easy to deal with. We're good. Now, let's pretend, because that's me picking x equals 0. Let's pretend that my next number was going to be 1. Right? I'm going to pick x equals 1. Well, 2x plus 3y equals 12. 2 lots of 1. Yeah?
Can I ask a question, please, Professor?
Sure.
Is it possible that I, to make it more simple for myself, to change it to its order, like, well, in Russian schools, we are supposed to rewrite these equations in order to make it 3y equal 12 minus 2x. Is it okay to do like that?
I don't mind. That works for you if you want to do that.
Okay, thank you.
So we get this. And then we get this. And then we get a problem. Would you agree 10 thirds is kind of awkward? It's roughly 3 point lots of threes. I don't really want to do that one. So I don't want to choose x equals 1. So do you see x equals 0 works well, but x equals 1 wasn't really very useful. And can you trust me that x equals 2 doesn't really work very well either. So what you do in these kind of questions is you can pick x's, and if they work, great. You can also pick y values. So does anybody want to give me a y value that I could maybe use and find out what the x that goes along with it would be? Pick a y value you think might play well with this equation. Any ideas? Any suggestions?
6.
That works. Let's try 6. So 2x plus 3y equals 12. We're going to use a y value of 6 and 3 lots of 6, right? So I get 2x add 18 is 12. Subtract 18 from both sides, and I like that choice. What made you think of 6? Was it just, it sounded like a good idea, or did you have a thought process behind it?
They all go into 6.
Ah, okay, so like common multiples. Interesting. That's a cool way of looking at it. I still need one more. Give me an x or a y to start with. A number for x or a number for y. That's what makes these so much more difficult. It's not just 0, 1, and 2 every time. You have to play about with it. Give me an x or a y that we could use. I'll have a guess. I'll tell you if it's a good guess, and if it's not, that's fine. We'll just pick another guess.
Eight for X or Y.
8 for y? That'll work. What made you think of 8? Just try it in your head and see what happened.
I mean, it's so far been, it's multiples of 2, so I figured it would work.
Yeah, why not? Let's show you why it works. I forgot what you said there. Why is 8? Yeah, right. So 2x plus 3y is 12. 2 lots of x plus 24 is 12. 2x is negative 12. X is negative 6. And we have got a winner. And so we now have 3 points that we can pick. Now, based on kind of the shyness of you, let's call it that, of what ones to choose and what ones not to choose, maybe we should think about it like a little bit like this. I very often pick x as 0. Now, 9 times out of 10, it's a great number and it works. And occasionally it doesn't. And sometimes that's fine. You just throw it out and try something else. Do you know who my second guess is after x equals 0? Who do you think I tend to pick after that? He isn't in this list. I always kind of try that one out because it's a good chance of working. Who else do you think I might try? Okay, you're not mind readers, I guess that. I like to choose y as 0. Isn't 0 a nice number to work with? It's an easy number to calculate with. And lastly, it very often works. Now, if I try y equals 0, won't this guy become 2x equals 12? And won't that give you 6? So do you see that the way I did it, that would have been my first two choices. And then I only need to go hunting for another one. And that might take me a few shots, but eventually, hopefully, eventually, right, I'll get one that works. And to me, one that works is one that gives you, a good number. So that's a little bit trickier, right? It's a lot easier when it's y equals to choose x's at work. We always do x's at work in that case. But when you get one of these, 2x plus y, 3y kind of things, you got to work on it. So let me pick an example. This is question 6. Now, they actually tell you which ones to use, but let's pretend they didn't. Okay, I need 3 guys to draw that line, and the equation is x plus 2y. So who shall I pick first? What number shall I pick, and is it an x or a y?
Zero?
Okay, do you want it to be in the x place?
Yes.
I agree. Now, if x is 0, doesn't this equation just become 2y equals 4, and so y equals 2? Do you see I can actually solve it without writing down a lot of stuff? Right. If x is 0, won't that just disappear and you'll be left with 2y equals 4? And that gets me y is 2. Okay, what's my second go-to guy that I like?
Y equals 0.
Right. Now, if you do y equals 0, don't you basically get x equals 4 without any effort at all? So that is my second one. So do you know now I only have to fight for one more guy, just to be sure. Give me an
2.
x or a y.
2 for an X.
Sounds like a good plan for me. And I'll probably do the working for this one, right? So x add 2y is 4. So 2 plus 2y equals 4. So 2y is, subtract 2 from both sides, and we get 1. And I now have the 3 points that I need to draw my straight line. A little bit easier the second time. Okay. Scroll through, pick another guy. Eventually, don't want that. Okay. Well, this equation, this is 11, or like 11 at least. I have x plus 3y take away 7 equals 0. So I'm giving you a really ugly one to do. Now, it's not quite written in standard form. So if I add 7 to both sides, there, it looks pretty. Now, what I told you about my favorite choices is still true, but they don't always work, right? You just got to know that they don't always work. If I put in x equals 0 here, will you agree that the y value is really ugly? I'll show you what happens. If I choose to make x equals 0 and find out what the y value that goes along with it is, then I take this equation and I get 7/3, and I don't like 7/3, so I'm not going to do it. So give me an x or a y that I could use that might work this time.
Could you use 0?
For who?
X?
Well, I've just done x. That's the one that we didn't like. But
Oh, I'm sorry. Y.
I like that one. I'll put it down there. Now, if you make y 0, x plus nothing gets you 7, so x is 7. Okay. 1 down, 2 to go. Sometimes it's just guess. But give me a guess or an inspired idea. I need 2 more ones. Give me 1 more. An X or a Y that might work with this equation.
Maybe X is 2.
Maybe it is 2. I'm doing it in my head. No, it doesn't come out great, but that's fine. You just chuck 2 off the list and you keep going. Try for another one. Maybe what?
4.
4. 4 I like. I'm doing it in my head, so I know it's going to work, but you're going to try ones that work and then you're going to try ones that don't, and if they don't, you just cross them out and keep going. So that's this one. 4 plus 3y is 7, because x is 4. Take away 4 from both sides and you get 1. So that's a good choice. I like that. So x is 4 and y is 1.
You could do X equals 1.
We could do x equals 1. I'm running short of room, but can I tell you it works? And if you check it out, it works and it gets you that one. So now we've got 4, 1, 1, 2, and 7, 0, right? You could either nice and easy and you can plot them and, you're good to go. Did you have a plan after the first one? Did you see anything that kind of helped?
If you're doing addition or subtraction, 4 goes into 3 and 7.
Right, so you were looking at something that worked with the numbers that are there. That works. People's brains work differently, so there's no one right way to tackle that kind of question. Sometimes, do you know, the answer could simply just be, just start at 1, then do 2, then do 3, then do 4. Do you know you're eventually going to get 3 that work, right? You might have to do 2 that fail before you find 1 that works, but you'll eventually get 1 that works. But it's easier or less work, at least, if you can do it without that. So is there any more of these to try out? I think there might be at the end. Let me check. So this is going to be question 14. And I have figured out how WebAssign takes care of big numbers. So you're going to see this in a few seconds. Right, I would rearrange this so it's in its standard form. I do a table. Okay. Give me an X value.
0.
10.
Yeah, 0. And if you do the work, you get 60. Give me a Y value.
0.
And can you trust me that it works and you get 60? Right, we're almost done with this one, right? Give me anything, an X or a Y. I'll figure out who the other guy is.
15.
As good a number as any. Do you know who the other guy's going to be?
45.
Yeah. Would you agree that that is a very nice equation to draw a line for? Because pretty much won't anything work? Right, if you picked 42, wouldn't the other guy be 18, right? You'd be able to plot anything. Right. So this guy ends up being 0.60. This guy ends up being 15.45. And this guy ends up being 60.0. And normally that would worry me until I looked at WebAssign. And let me show you why it doesn't worry me and won't worry you either, I hope. Because normally WebAssign just does the 10 to 10 thing, right? look what it did for this question. Do you see it made the numbers bigger so you could use them? So my table had 0, 60. So click on that. 0, 60 is there. And the next point I've got is 1545. Now, 1545 is very, very hard to do correctly. So I'm just going to click there. And then I'm going to go over here. And I am going to change that to 15,45. And then once I'm happy that I've got the two guys, wouldn't I then hit the little button down here and I'd get my nice green X and I know I've done the question right. So it looks like, back to Nadia's problem, if the numbers are really big, Nadia, I think what WebAssign does is it just gives you a bigger table with those numbers. Now, as you can see, it was quite hard for me to plot that point accurately. So I didn't really bother because couldn't I hit this and fix it after the event? So as long as you don't hit submit, can't you tweak it until you're pretty sure you've got the line where it needs to be? And as a double check, do you see that guy there?
Mm-hmm.
Isn't that at 60,0? Isn't that where my third point would have been, except I didn't need to use it? See that third one? 60,0. Right. How about one of the more standard ones? You want 4, 1. That's my first point. This is question 11. Then I want 1, 2. There we go. Just, I'm pretty sure I did it right, but just check. Yep. And you're done. Now, compared to finance formulas, that's not anywhere near as bad, is it? Compared to normal CDF questions, this isn't that bad either. Agreed? Compared to it.
I'm sorry, Professor, I couldn't understand how do you calculate points?
Well, in general or a specific question?
This how do I graph the line? Whereas y equal 3 or just...
Oh, we haven't done that yet. We
okay.
haven't got to that yet.
Okay.
But we will get to that.
Okay.
Right. Okay, let's have a little pause. Actually, I'll make that the next thing we do after this, so we can show you how that works. Okay, so let's give you 2 questions to do. Three half x minus 1, 2x plus 5y equals...
Professor, could you share please what you are writing?
You mean you can't see my questions? Damn it. I can see my questions, so I'm happy. You want to see them as well? Okay. There we go. Here's 2 questions. I want you to just do the table. Find 3 points at work for 3 upon 2x minus 1 and find 3 points at work for 2x plus 5y. And I'll give you what? I'll give you 3 minutes. And that's where I'll be putting my answers.
Are you waiting for people to give you the answer?
Not yet. I'm giving you all 3 minutes, but hold that thought, Jed, because it sounds like you've got the answers already. Did you get the answer to both tables? That was very quick if you did.
Well, I don't have my calculator, so I'm just kind of guesstimating.
Okay.
Graphs used to be hard, but they're kind of easy. It messes me up when it is the fraction, but how you showed how you do it, then I was like, oh yeah, okay, got it.
Good. That's good. Okay, last 10 seconds. Now, there are going to be lots of correct answers to these tables. So just because the answers that end up in my grid aren't exactly all yours, doesn't mean that you did it wrong. It just means you found a different right answer, right? A different point that you could plot. Okay, let's do the top one. When questions are of this form, right? The slope-intercept form, as it's called, don't we just pick x's? And as long as you pick good x's, you should be fine. So what would be the x values that would work well with this straight line? What x value should I use with this straight line?
0.
Agreed. Just call it out whenever you feel comfortable.
Oh, 2. 4.
Now, if you plug in 0, you get -1. If you plug in 2, let's see, you get 2. And if you plug in 4, you get 5. So that would be a combination that works. And are there others? Yeah, there's tons of them, but that combination works. Okay, the second one, the standard form, that's a bit trickier. So give me, I don't know, give me an x that works, or a y that works, whatever you found. Give me an x or a y that works with nice numbers. Come on, don't be shy. Tell me
0.
an x. Yeah, 0 for who, x or y?
X.
Right, if you plug in 0 for x, you get 2. That works well. Give me another one. Anybody?
X equals 5.
Well, that's an interesting one. Because if you do that, you get 0. So that one works.
X equals -5.
I never thought of that one, but I know that one works. Did anybody get any other combinations? Because that's just 3 that we happen to have, but anybody get any others that work?
I used x equals 10.
Right, now if x is equals to 10, I think you trust me on this. I think you get 2. Do you get 2 with the other guy?
-2.
No, -2. Thank you. You're right, -2. So that works as well. You agree there's lots of right answers. You just need to find 3. And that's going to be the end of that part of the list of things that we were going to cover. So we've pretty much covered most of this with Nadia's little bit now. Yeah, well, not Nadia's, everybody's. There are 2 special kinds of equations of lines that don't look like any of the others. They will be a y equals a number, and there will be an x equals a number. And when you want to graph those guys, you really tackle it a totally different way, right? These guys are very special lines. So let's kind of do it on this one. Where's my square paper? Oh, here we go. Y equals 7. Basically, what that is telling us is that you want to plot all the points whose y coordinate is 7. Now, if you want to do a little table, it would look like this. The y is 7. And just pick anything you like. Now, if you want to sketch what y equals 7 looks like, it's a horizontal line. 1, 2, 3, 4, 5, 6, 7. And y equals 7 is a straight line. And it has only a horizontal line to it. So that's what y equals 7 looks like. Now, do you know what y equals 2 looks like? Would be a line roughly where my pen is. Y equals -2 would be a line down there. So drawing equations of lines which are y equals a number ends up being horizontal lines each time. And in this case, it is 7, but it could be at 2 and something else. So now that I've shown you what this guy is like, it might look at what this guy looks like. Now, in this question, the x values are 2 every single time. So who's the y values? Anybody you like. Because when you plot the straight line x equals 2, what you get is a vertical line. Because on this vertical line, isn't every single point on this line going to have an x coordinate of 2? So those are two very special lines. X equals a number, y equals a number. So can you imagine when you draw them on graphs, you really just need to plot a couple of points horizontally at 7, or a couple of points vertically at x equals 2. So let me think.
Sir,
Yes.
can I ask a question, please?
Yes.
How do we call this kind of equation?
What do we call them?
Yeah, how is called this equation y equals 7? Is there a special like a name for it?
Oh, well, the name that you can use is horizontal line for the y equals, and vertical line for the ones that are x equals. So a horizontal line is y equals 7. That's an example of one of the horizontal lines you can get. And x equals 2 is an example of a vertical line. Okay. So that would be the x.
Thank you.
You're welcome. Let's have a look at how that would work in WebAssign. Right. Suppose you want to graph the line x equals 6. Well, pick a point like 6, 0, and pick a point like, I don't know, 6, 5. There you go. That's pretty easy, right? X equals 6, 0, 6, 1, 6, 2, whatever you like. 6 something. Plot your other point. I picked 6, 5 because I wanted to show you the coordinates. There they are, 6, 0, 6, 5. Vertical line. Suppose I wanted to do a y equals 7 kind of question. Well, y equals 7 would be things like 0, 7. Oops, forgot. Would be 0, 7, and maybe, I don't know, 6, 7. You see, it's a horizontal line. Just make sure they have two lines the same height. In this case, it's 7. So that's what y equals 7 would look like. If you keep your mouse pointer, the middle mouse pointer on it, you can actually move points around. Kind of cool to play with it. There's a vertical line, x equals 6. Are we comfortable with those questions? X equals a number and y equals a number. Do you need to say More examples of that, or do you feel comfortable?
I think we're okay.
We're okay, good. Okay, then if that's the consensus, I will move on. And we'll now look at the next puzzle. There's only 3 questions like this. You're still going to be graphing lines. Everything in this page is to do with lines in some way or other. How do you graph lines when you're told the slope and the point on a line, right? So you're just given 2 things, the slope of the line and the point of the line. And bear with me for a few seconds. I'm trying to find some more square paper. Well, I got that one I can do. Got a bit of that one I guess I can use. I had more paper than that. Where's the rest? There's a good one. Good. So before we get into doing those kinds of questions, let's give you a kind of early start on some of the things that we need to kind of be used to. When we talk about what is the slope of a line, we normally use the letter M, and let's say the slope is 3. And I'm probably in the wrong place, aren't I, again? There we go. So when you see M equals 3, they are telling you that the slope of the line is 3. If you see M equals 4/5, they're just telling you the slope of the line is 4/5. Now, a normal way of looking at a slope is to think of it as being made up of 2 numbers, a rise over a run. If the slope is a whole number, just make it over 1. That way you'll have a rise and a run. Right? In this case, the rise is 3 and the run is 1. In this second case, the rise is 4 and the run is 5. Now, that's going to help us to draw a line. So let's show you how that would work. Imagine, I need square paper here. Imagine I just wanted to do a slope of 3. Right? Doesn't matter where I draw it, I'm just interested in drawing a line whose slope is 3. So I'm just going to pick a random spot. When you imagine a line that is the 2 numbers that we call the rise and the run are these guys here. That distance there is the rise, and this distance here is the run. So I start here, right? And I run, well, let's put some numbers on it. Let's say 4/5. Let's do that one. I run 5. 1, 2, 3, 4, 5. That's my run. And my rise is 4. So once I finish running, I then get up. And that's where I finished. I started here and I finished here, and the run is 4. And when you join them together, that line has a slope of 4/5. So your run and then your rise. Suppose I wanted to do a slope of 3. I'll just pick a point. Which one of these 2 numbers is how much I should run? And you always run to the right. 3 or
Y
or 1?
and 4 is 4x line. Or
Yeah.
1 is 4x line.
Yes, 1 is for X. So you go and you run 1 box to the right. That's the run. And the rise is 3. 1, 2, 3. And there's your guy. If you write the numbers down, how far along and how far up, right? What your run and your rise is. Do you see it kind of looks like, if I draw this one again? Doesn't it kind of look like 4/5? You see it? 4/5? Kind of looks like. Yeah. Let's try another fella. Suppose I wanted to do a slope of 3/7. then I pick a point, and I realize that the top number is the rise and the bottom number is the run, and I go 1, 2, 3, 4, 5, 6, 7. That gets me to there. And that's the run, right? It's 7 units to the right. And then from this point, I then do a rise of 3 boxes. 1, 2, 3. That's my rise. And that's 3 boxes. And start to finish. Rise over run. You see, you run before you rise. Are we good?
Professor, can I say something?
Sure.
If there will be a minus, that means for run we go to the left side and for rise we go down side. Is it right?
Well, let's show you that. That's kind of where I was going to go next. So you're in the right place. Let's do a negative 4/3, right? So a negative slope. Now, I can tell you right now that positive slopes always go uphill. So as you travel to the right, you always go uphill with a positive slope. On the other hand, if it is a negative slope, you always go downhill. And if you're wondering how do I know that's an uphill and a downhill, you always travel to the right. If you go uphill, it's an uphill. You always travel to the right. If you go down, it's a downhill. So that's how I know that. So I know this is going to be a downhill slope. Right? So I would start, and the negative goes to the top guy. That's the way I do it. So negative 4 is on the top guy. So the run is 3. So you go 1, 2, 3. There's your usual run, and it's 3. And then the rise is negative 4. That means go down 1, 2, 3, 4. So do you see that when you join the start to the finish, that's what negative 4/3 looks like. Okay. Let me try and do negative 4/3 on square paper. I'll start here. The run is 3. 1, 2, 3. That gets me to here. That's my run. My rise is negative 4. Now you can see it's going downhill. Then you join the start to the finish. And that's what a line whose slope is negative 4/3 look like. The most common mistake that people make with this question is that they get the 4 and the 3 mixed up, right? They make the rise the run and the run the rise. But if you do it in this way, right? Bottom number first, that's the run. And then a rise either up the way or down the way. If it's negative, go down the way. If the top number is positive, go up the way. And you've got your thing. So we're now going to put that together and show you that I think it's 3 questions that do it. Let's find one of them. You're being asked to sketch the point 5 halves and the slope is a half, okay? So I'm kind of going to do it in paper, then we'll show you how you do it in word design. So I know where to start. I start at 1, 2, 3, 4, 5, 2. I start at the point with coordinates 5, 2, which is here. And now I'm going to do a slope. So the rise is 1 and the run is 2. So starting here, a run of 2 takes me to there, and then I rise up 1, takes me to there, and that's where I finish. And I have a start and a finish, and there's the guy you want to do. So plot the point 5, 2, use that as your starting point, do a run of 2 and a rise of 1, and you've got it. So I'm going to nip over to WebAssign. If I can get this thing to listen to me. We'll see how it works. I think I can make this a little bit bigger. That might help some of you with the smaller screens. Yeah. So, click on this guy. Done. The coordinate is 5, 2. So 5, 2 is there. Now, 1/2. Rise is 1, run is 2. So from here, run 2, rise 1. There's your answer. That makes sense? Start at the coordinates and then do the rise over run thing. Okay.
If you get one that's a 0, like I'm trying to figure out how it would plot.
Oh, this one. Let's do this one.
Doesn't give me anything.
Right, here we are. Can you see question 9? It's got a 0 in it. Let's do that one. Right, the point is 6, 4. So 6, 4. Put a dot there. A slope of 0 is a very weird slope.
Can I say, Professor?
Yes.
You will need to find such a number. In order you divide rise and run, and then you will see a 0.
Yeah. And what does a 0 slope look like? So I'm starting at this point. Couldn't a 0 slope be 1 along and none up? That would get you 0.
For example, if y equal 2 and x equals 0, then we will receive 0.
Yes, that's correct. So your question, Tara, is how do you do a slope of 0? Well, plot the first point, 6, 4, which is this one, and then plot another point which has no rise. Right? A slope of 0 means you don't go up or down at all. You just go horizontal. So all I did is pick a point next to it. I could have picked that point there, right? Or that point there, or I guess I could have picked that one. I don't think I want to, but I could, right? And you end up with a horizontal line.
So you can pick any number then. If you
As
give
long
you
as
no, if there's no slope somewhere on that same line.
Yeah, any guy you like in that line will do the job. Right, I think there's one last one to do. Yeah, there is. Let's do the -3/4 one, right? So you're starting at the point 5, 0, which is here. And you're going to do a slope of -3/4. Well, if I had my paper here, I would write it down. But isn't the bottom number the run? And that's 4. So 1, 2, 3, 4. That's me here. The top number is -3. You always give the negative to the top number, right? The top number is -3. So that's the run is -3. Do I go up 3 or down 3 now?
Yeah.
So here we go. 1, 2, 3. Gotcha. There's your answer. So do you see that slope is -3/4, right?
When you're doing them, you always, when it's a negative, you're always gonna do your run out and then drop down.
Correct.
Okay, so I did it the other way like 4 times. And I was like, why doesn't it work?
Well,
And then
undo it and do it.
but I just want to
that
know
way.
if there's a reason that you have to go that direction versus.
Well, when you got a number like -3/4, it's easier if you give the negative to the top guy because the run is always positive. Then all you need to do is travel to the right every time. So you don't need to change that. And the negative or the positive can be the rise. So positive goes up 3, but -3 goes down 3. And that's how you get the separation between plus and minus slopes. So the reason we do it that way is that it tends to make it easier to sketch, isn't it? If you always go to the right and then you decide up or down, depending on positive or negative top number. Are we winning? Are we still in the game here? Are we happy? Right, I want to get the last 2 questions out of the way so we can call this one done. So if you can hang about with me, here we go. They're very quick questions. And I think we're all getting the same question, so we're all going to get the same answer. Now, can you remember scatter plots and drawing straight lines or box plots or anything you want to call them? Do you ever seen things like that where you try and draw a line through some data points? Okay. Our question is basically ignore all the dots. Just focus on the line. One of these equations is the equation of this line. And there are two features you're going to use to figure out which one it is. The first one is called the y-intercept. Find out where the line meets the y-axis. Do you see here it meets it at -2? So only pick equations that have a -2 on them. So that's the second one and the third one. Do you see these two guys here? None of the others are correct. If it crosses the y-axis at -2, the number at the end is going to be -2. That's called the y-intercept. So that's why I'm picking either guy number 2 or guy number 3. Now, the other part of it is the slope. If you look at this question and you draw a little rise and run, right? You make one of my little triangles. You see that little triangle here, roughly? And what would that look like? Well, it would look like a run of 3 and a rise of 2. So that would be 2/3. Can you see that distance is 2? And very roughly, that's 3. Can you see the guy I'm trying to draw here with my up and down arrows? What does 2/3 look like roughly as a decimal? What number is 2/3 very roughly as a decimal?
.6666667, so 0.7.
Okay. So yeah, so just pick that one. And that's why the third one is the right answer. Right, one last question. Let's look at this guy. What number is the y-intercept?
4.
And that means I'm going to pick either this guy or that guy. Agreed? They're the only two that finish with a +4. Now, if you look at this guy and you look at this guy, very roughly, do you see my triangle? It's 4 and it's 8. Would you agree that's roughly a half?
Yes.
Isn't it sloping downward? So it's roughly -1/2. So that's why I picked that one. Y-intercept is 4. And that slope is roughly about a half. -1/2 because it's pointing down the way. Oh, I did forget this one. Okay, I've got this one. Let's do it. Population of Texas was 17 million in 1990 and 19.8. No, we don't know. Do we have time? When does this class finish? Have I overshot you?
3:15.
Oh God, we've tons of time. Well, I'm thinking of them an hour out. Okay. I thought we'd done 2 hours and we'd only done 1. That is good news because we're going to be finished this very early, and that's fine. So I can spend a little bit more time than just rushing through the last question because that's kind of my goal for today. Right, so you're told that the population of Texas was 17 million, and that was in 1990. And it increased to 19.8 million in 1998. So that only took 8 years. And then it goes and does this. You can't see it, but I'm reading it out to you. Let 1990 be the base year. They said, let's call that x equals 0. So that makes 1998 x equals 8. So you happy about that? Just way of rearranging it. And they tell you that in the instructions. Now, y is going to be the population of Texas. In year X, right? So these guys. And so we have to try and create an equation, right, that represents the population of Texas. So y equals this number here is the y-intercept. If you imagine x equals 0 you would get that guy there would be 17. So 17. And now the hard part. I need to find what the slope of this line would be. Can you imagine it would go something like that? Now, I know the coordinates at x equals 0 was 17 million. And I know the coordinates when x is 8 is 19.8 million. And there is a formula for calculating the slope, which I'm going to tell you right now. And I'm putting some labels on things. This point here, the first one's going to be called x1, y1. And this guy here is going to be called x2, y2. And the formula is y2 take away y1 over x2 take away x1. It's basically the rise and the run. And so what do I get? I get a y2, which is 19.8, take away a y1, which is 17. And on the bottom, I have an x2, which is 8, take away an x1, which is 0. And that gets me 2.8 divided by 8. And that gets me 0.335. So the equation that they want is that line. The y-intercept is 17 because the y-intercept is always the value when x is 0. The slope, we had to do this calculation, but the slope ends up being 0.35, and that's x. And that's the answer to question A. And now the answer to question B. Use this equation to predict the population of Texas in the year 2008. Now, in the year 2008, we don't make x 8. We have to figure out what x would be for that year. So, if 1990 counts as x equals 0, and 1998 counts as x equals 8, won't the year 2008 count as x18? Right, let's see how I did that. If you look at 1990 to 2008, isn't that 18 years? Right. From the starting year, the base year of 1990, to the year 2008, that's 18 years. And the answer then is x equals 18. So what's the population going to be? 0.35 times x, add 17. And we have 0.35 times 18 plus 17 more. And evidently, the population of Texas is 23.3 million. And that formula basically is estimating what the population of Texas is. I'm going to pretend there's a question C then. What's the population of Texas right now? Okay. If 1990 is the base year, that's the year that we use to start the thing, and we call that x equals 0. What number for x is 2021 going to be?
$31.
I agree. If you subtract the years, don't you get 31 years have gone by? Right. So what's the population going to be? Why the population right now in Texas should be using that formula. 0.35 times 31 plus 17. And we're going to go 0.35 times 31, and I'm going to add 17. And the population of Texas is going to be 27.85 million. you think that's accurate? Does anybody even know what the population of Texas is? Because I'm about to find out. And I'm typing this in, population Texas. And in 2020, come on, tell me the population, I need a number. And the population of Texas was in fact, the real answer, 29,000,000.49. A little bit out, but it's not bad. Great. A couple of million out, but not bad at all. And I think one of the reasons for that is that, from what I've heard anyway, there's been a lot of people going to Texas in the last year or so. So it's probably increased quicker than it typically would have. But that's still a good guy. So I'm pretty much finished for what I want to cover today. I'll see you on Tuesday. What I'm going to do now, because I know a lot of you don't get to do officers. So what I'm going to do now is hang about, and you're going to ask me homework questions, and my calculator doesn't work questions, and any other kind of question that you want. And for those who don't have any questions, remember to say hi and then bye-bye. Hi. Bye. So who wants to start the ball rolling? Who's got their first question?
May I go first?
Sure, go for it, Gabe.
I still have to do the normal curve homework. Is it okay if we go over numbers 19 and I believe it was number 8?
Okay, I can do that. Give me a few seconds to just find the homework. So it's the normal curve, so that's section 14.3, right?
Yes.
Yeah, 14.3, and I'm going to do, I'm going to reduce the window screen so I can actually read the damn thing. It's tiny. Where are you? Okay, gotcha. Click on it, Gabe. And your last name, Phillips. LMNP. I've lost you. And there you are. So it'll take you just a little while, but I will get there. So what was the question that you wanted me to do first?
Number 8.
Okay, let's click on that. And we'll show you what we have here. So it says, suppose the heights of people are normally distributed. The mean of these people, so this is question 8. The mean of these people is 170, and that the standard deviation of these people is 40. How many would you expect to be between 165 and 175? Now, the difference with this question is they tell you that if you picked 40 people at random, how many would you expect? So this question is going to be in 2 pieces. The first thing I'm going to do is find the normal CDF. And I'm interested in people who are between 165 and 175, right? So the normal CDF is 165, the lower bound, 175, the upper bound. Right, so that's lower, upper. And then you do mean, and then you do standard deviation. So you then do 170, and then you do 40. So I'm going to be doing, oh, I switched places. I am going to be calculating the normal CDF of a 165, 175, mean of 170, standard deviation of 40. Now, it depends on if you've got the old or the new calculator. Since I've only got the old one, I'm going to do it the way I would have to do it. So second vars, choice number 2. That's the same on both kinds of calculators, except Tara, who's figured out how to do it in her calculator. Enter. Then you do the lower number, comma, the upper number, comma, the mean, comma, the standard deviation, and you close the brackets, and you press enter. And this is only the beginning. This is the first part, 0.0995, right? That's roughly rounded off. But the question didn't want to know what that is. They wanted to know something a little bit different. Out of 40 people, how many would be in this range? So what you do is you just do 40 times this guy, and that'll tell you how many out of the total you would expect. So this is about 9–10%. You're going to do it to this guy. So if you go 40 people with the probability of them being that range being this number, you will get about 4 people, because you round it off to the nearest whole number. Does that make sense?
Yeah.
Right, so that's the extra kick, is this bit. A lot of questions, you just find that number, maybe as a percentage, and you're finished. But in this question, you had that to do as well. And in question 9, it's pretty much the same thing, right? You have to do this, and then you do a multiplication. In question 9, you're going to be doing it with, what, 80 people instead.
Okay.
Okay, right, so we'll just kind of circulate. If you've got more questions, just hang about and you can join in when someone else has had a shot. Okay, who's next for the questions? Anybody got a problem?
I wanted to do number 19 in the same homework, if that was all right.
I can do that. Anybody else got a question before I start 19? Okay. Then in question 19, just getting to it. It's the diameter of a pipe question, right? Is that the right one? Now, they were sneaky here. They told us the mean, which is totally okay. There's nothing wrong with it. But they didn't tell you the standard deviation. They told you a thing that was called the variance. And that's what's sneaky. And the variance is, in this question, was that. But I don't use this number. I use the standard deviation. But this number will allow me to get the standard deviation, because the standard deviation is the square root of the variance. So if I want to get the standard deviation, I just take the square root of this number, and that ends up being 0.04. So now I have the two numbers that I do need. And so if you want to find what's the probability that a pipe is bigger than 0.61, so you're trying to find the probability that it's bigger than 0.61, you can do the normal CDF guy. It's going to be normal CDF. If you are doing a bigger than, you go 0.61 comma. What number do you put after the 0.61 then if you want something to be bigger than it? We put a special number here. What do you put when you want that?
Was it that like 99991?
Yeah, as many it is as many nines as you feel you want. That's plenty. Probably more than you need. And then you put in the mean, which is still 0.3, but you don't put in the variance, you put in the standard deviation. So I can now go to my calculator. Second, number 2. It's going to be 0.61 comma, lots of nines, comma, 0.3, comma, 0.04, close it and enter. I did something really wrong here. What did I do? There's something not right here.
I also got that too.
Oh, I know. I scanned down to the next question. The question 19 didn't have 0.61. Question 19 had the number 0.34. That's what went wrong. I read the wrong data. Right, so I got the wrong number. Right, so I'll get it with the right number now. So it should be 0.34 or bigger, not 0.68. 0.60 thing is the next question. So 0.34, comma, lots of nines, comma, nothing 0.3, comma, 0.04. Finish it, and that's much better, right? And by the way, that's a 2. Let me do question 20, because I screwed that one up too many times. I mean, I got the answer at the end, but not at the beginning. So in question 20, and this time I'm going to scroll the thing up so I don't see the other data. There, that's much cleaner for my brain. In question 20, same story, very similar story. You get a mean of 0.3. You're told the variance is 0.0004. So that makes the standard deviation the square root of 0.0004. Right, my screen just disappeared on me, guys. If you hold on, try and get it back. Okay, I think I got it back. I've lost it. I've lost my screen. Okay, where are you hiding? That one can go away. I think somewhere when the flicker went, I went and wrote or read the wrong numbers again. So try and bear with me. The thing went away, and then when it came back, I read the wrong number. So question 20 does have a mean, but question 20 has a 0.6 mean. It has a variance, which I think I actually did get the same number, 0.004. But the standard deviation is going to be the square root of that number. And on my calculator, the square root of 0.12304 is 0.02. Okay, that's good. Now we are being asked in this question, what's the probability that it exceeds, that's bigger than 0.61? So that's going to be a normal CDF. Bigger than 0.61 is that guy again. The mean is 0.6 and the standard deviation is 0.2. So when I go to my calculator, it's going to be choice number 2, 0.61, comma, 4 nines, comma, 0.6, comma, 0.02. And when we finish it, we get 0.3085, which I can verify is in fact the correct answer. So what was wrong with 19 and 20 is that they were sneaky. They didn't tell you the standard deviation, which is what you needed. They told you this thing called the variance, and it's the square root of that variance is your standard deviation. It would have been much easier if they just told you that, but they didn't.
Okay. Yeah, that's okay. That makes sense. Thank
Aubrey,
you.
you're welcome. Aubrey, have you got a question for me?
No, I usually like to stay to see if they
Nothing
ask
wrong
the same
with doing
questions
that,
to me.
kids.
But I did have something. I noticed that you changed the due date,
Yes.
right? Okay, I thought I was imagining it. But that 15.2, the other homework,
Yes.
like, are you going over that next class, or is it one of those things where we already know it because it's similar to the other
Oh, you mean,
sections?
is that put down as the homework? Because that, if I did, I should move it because that was just a mistake.
Yeah, it's 15.2 because we did 15.1 today.
Yeah,
And then there's 15.3.
Yeah. We weren't going to get 15.2 done today, even if I'd started it. It's too big. So let me go in and fix that so you don't have the issue. So it's due on the 1st of June, so it's not even due.
Yeah, June
So
1st.
Yeah, so it's just, oh, I gotcha. Yeah, June the 1st is not good. Let me
Which
move
is
that
a
guy.
Tuesday. So I
Yeah.
thought like you were going over it in class and then like we did.
No, I didn't mean that. I know that's what it sounds like I meant, but I didn't mean that. I'll just move this guy to a safer number.
Don't you love when you lose time?
What was that?
I said, don't you just love when you lose time? And
Yes,
that's sooner than I think it is.
Right, so that guy has now disappeared, I hope, or at least changed. So its due date is now miles away. It's another, 6 days away. So don't worry about it. When you come in on, when did I get used? When you come in on Tuesday, we'll do that guy on that day and in the next section.
Okay, perfect.
Okay, so I'm glad you pointed that out to me because it wasn't obvious to me that I'd done that.
Okay, I do need some help on a few things. I know that I know what I'm doing on some of these problems, but for whatever reason, when I went back in to do them, what I wrote, what I can figure out, I was telling myself to do, like, is not working. So I was having problems when you have the Z score. I wrote in here that I'm supposed to take the mean plus the score and divide that by the standard deviation.
Right, stop
but
there.
Every time I do it,
that's not the right formula. So my writing was wobbly or your copying was wobbly. So let me show you what the correct Z score is. My camera has just went wonky.
Because I have all those questions for the Z score and I did 1 or 2 with you. So some of them are done, but even trying to replicate it, I was like,
the score, the Z score formula is data, whatever that means, take away the mean, divided by the standard deviation. So what I heard you say is you add, but you don't. It's the data take away the mean.
Notes here. Okay, now I see. I do see that. I wrote data minus mean SD, and then it was copied. It was done different. Maybe a different problem had it. I had to do something different.
No, they're all the same formula. Right. Now there is a difference. Sorry.
So the data in this would be like the mean, basically, right? Is that the data for it, or I don't have?
No.
Because I'm doing like question 12 on the homework you were just working on.
Okay, here are the 2 formulas that you're going to be using. The top one is for calculating Z scores, and the bottom one is for calculating data when you know the Z scores. So you're either being told the data, the number to use, and you're being asked to find what Z score that matches with, or you'll be told the Z score and you're asking what data point would be that. So let's go and look at your question that you're talking about. So what section is this in?
Oh, I think that's what I messed up too. Mean, and then the mean is, you said plus or minus?
Well, no, you don't need the plus or minus. I take that back. You only need plus. The z-scores plus or it's minus. I think that's what I was trying to say in my brain, but I shouldn't have wrote it down that way.
Yeah, and then you multiply it with the z.
Yes. So what was
So I
the
think that's
question? Yeah. What was the question you were trying to do? And we can look at it.
Okay, so the one I was trying to do was number 12 on mine. So that normal distribution has a
Okay.
mean of
Right. Hold
85.
that. Right. So I'm ready. It has a mean of what? 85.
Has a mean of 85.8.
Okay.
A standard deviation of 4.82. And then it says find the value corresponding to the z given, and the z given is 0.63.
Right. So when they say the word value, I want you to think of that as the same thing as data.
Okay, value.
So,
So then I
right.
don't have value, so I need to
Right.
use the z
So
score
so you're going to be using the top formula, right? So I'm going to call it data, and then I'll write down value. And it's going to be the mean, which is 85.8 plus a z-score and a standard deviation. So it's what, 4.82 multiplied by 0.63. So I should be able to do that all in one go. And so it's 85.8 add 4.82 times 0.63. And I'm coming up with the number 88 point. Well, it depends how much they want rounding off.
Oh, 84.
Usually
it's 4 decimal places.
Okay, if it's 4 decimal places, you want 8366. Because that's 4. If it's 2 decimal places,
this one doesn't even let me put it back in. I'm past the point. I didn't realize number 12.